Hi, everyone. Thanks for joining me. This is the first time I've attended a conference quite remotely like this or presented remotely. And I presented a couple of times, but generally sort of lives, but this is pre-recorded. So forgive me for anything that's sort of not flowing as nicely. So it's new experience for me pre-recording something too. But yeah, so I'm Hoang. I'm from Energy Australia. I'm a lead data scientist at Energy Australia in the customer division. My responsibilities at the moment include our cloud migration and make sure we land in the cloud successfully, and then making sure that we realize the benefits of moving to cloud. And I guess that's really what I'm here to sort of present around today, sort of our experience so far moving to the cloud, and one of the back office opportunities that we've been working through and are still working through, and some of the learnings from that. And hopefully you'll find that useful. So without further ado, let me share my screen and get cracking. So really, we're transitioning to the cloud at Energy Australia, and I guess one of we wanted to focus on was really how there are generally processes through our back office that are quite challenging to perform, and they also represent large commercial opportunities. And in that transition, we've found sort of some opportunities to optimize things, and I'm going to talk through some of that today. So ultimately, we're going on a cloud journey, and it's not going to be an easy journey, I guess. One of the things that I will be going through, sort of in this cloud journey, is we're actually just not migrating. Just people like to think of cloud migration as just doing stuff like that, but what does that actually mean? At Energy Australia, where we are, we have a cloud data program, which is basically committed to moving across our customer division, our markets division, and our pretty much the entire enterprise across, but also our analytics framework. And sort of, I've been sort of been part of that journey now for a couple of months, and it's an 18-month program, and really what sort of we're aiming to do is transition a lot of our data and our processes into the cloud. At the moment, we kind of have a couple of different systems, not as many as other organizations. So I think there's other organizations that I've worked with sort of in the past that have, like, probably 8 to 10 different source systems. Energy Australia, it's 2 to 3 really that we have, but we're looking to move a lot of that into the cloud and sort of gain the benefits from that. Um, it's not been particularly easy, as you can imagine. Trying to do a full scale sort of migration is hard. There's new things to learn in the cloud as well. And if I'm perfectly honest, some of those things are things that you do on-prem in a certain way, but because of the way cloud works, there's a detachment between the way that you have compute, which is basically your servers, versus where the data is stored. Generally, those two things are together. That optionality is something that's very valuable, as I'll touch on later in this presentation. But ultimately, there are a lot of moving parts, as I say, when you move in the cloud. There's a lot of tools. So we're moving probably from a tool set on-prem about 5 to 6 items to probably 15 to 20. And that is actually when I say we move into the cloud, that is one of the challenges about how you move into the cloud. Often people lose sight of the fact that moving to the cloud means that um, the optionality means that you need to have different tools to manage the optionality, because you can plug and play in multiple places and choose where you want to use different tools. That also introduces a whole range of tool sets that your teams ultimately need to master to make that transition possible. So I wanted to spend a couple of moments, I guess, right now, just really prefacing that is one of the initial challenges, locking down that tool set, thinking around what is the right opportunity from your organization and your maturity to use certain tools, because certain tools may only be appropriate certain times. So going through that process is something that's really important ultimately. So I don't want to sort of spend too much time on it, but I thought it was very important to call that out very early on, because it certainly matters as we go through this presentation. So a bit about Energy Australia and the energy industry. Most people probably think of energy as quite simple. You go home, you flick your lights on, bang. That's how energy works. You don't think twice about it, but it actually is quite complex. So what I have on screen here is pretty much the 4 types of usage we have. As a customer, you probably think, there's only one type of usage that I care about. That's the energy that's going. But the way the market works, there's actually 4 different metrics for what we define as usage that's used by our customers. The first block there at the top is purchase volumes, and purchase volumes are effectively a high grain sort of set of data, which is not at an individual customer level. It's generally collected by area, and it's the energy that's used in an area. It generally that sort of data occurs so it gets generated quite quickly. So we'll have that within sort of the day or so of when sort of things are done, but it's done at a higher grain than the individual customers. So it's quite useful for an organization because it gives you an indication of how much your customer base is generally using at the start. Then from sort of that's one sort of form of usage data that we have. The next one that we have is basically the meter data that comes up from AEMO. That's really important, obviously, because in Victoria, there'll be smart meters. In other states, not so much. You'll be probably still things that are basic meter related. But effectively, this is half-hourly data that is of a high grain, very useful for us to understand customer behavior and patterns. That's pretty much the smart meter data or the meter data that we can receive from the market for the customers that we own. So that's another data set we have. Now, another sort of usage data set that we have that people probably don't think about is network usage. Network usage comes from different distributors who get energy into the households. They pass energy through the wires and they measure how much energy goes through those wires. That's obviously something slightly different to what the meter data that AEMO is tracking. AEMO tracks the data system that individual meters use, whereas you think about what networks are doing, they're calculating what energy is flowing through the system to get to those meters. So there can be a slight difference between those, but it becomes another source because ultimately the networks are only allowed to charge retailers, which Energy Australia is as well. What passes through their transmission lines. So we get another form of usage data from them as well. Lastly, the final type of usage we have is what is the build usage. So the retailers in the energy industry bill customers all the time. They bill them on a fairly regular basis, and what that allows them to do is obviously get money. And that's obviously a very important form of usage that we charge customers for. So you can see there that even though when I say energy usage should be simple, we already have 4 sources. And one of the big activities that we need to do in our industry is make sure that these 4 elements line up between each other, because obviously you can't be billing customers for more energy than they've actually used. But also you don't want to, from a network side, be charged for more usage than you're actually charging out to your customers. So if, for example, a network is saying to you that, hey, you use 100 units, when we actually think we only use 95 units, we don't want to be paying those extra 5 units. So really, this reconciliation process is really important between these 4 different volumes, and we don't want to be telling different things, because the difference when you think about Energy Australia's customer base, which is about 2.5 million customers, that's quite significant. We're talking about in the millions of dollars that you could potentially be out of pocket. So reconciling usage, as I've alluded to, is actually a really big key back office item. It's a source of revenue leakage for the organization, and one of the things we obviously want to do is mitigate that. So if I talk to these data sources, if I can sort of summarize what we've been saying, is that we're sort of saying purchase volume is a fairly small data set, whereas the EMO volumes are fairly large data sets, and then you've got basically large data sets as well. Sorry, EMO data sets are basically big data because they're half-hourly reads for every day of the year. Then you have network data, which is large data too. It's quite a high grain. And then lastly, you've got sort of a medium-sized data set in terms of the build data. Now, you add the complexity of where are those systems today? What environments are they held in? So I haven't gone to the specific names to Energy Australia just because that doesn't really matter, but it's generally organizations have some form of this. So we have purchase volumes on one particular environment, and then we have the smart meter data on a separate environment to that. And then we also have the network data on that environment too. So you can see immediately that they aren't in the same place. And then lastly, then you've got a third environment, basically the billing system is where the retail bill volumes come from. So you can see there that what you start to look, there's different grains of data, and then ultimately there's also different environments in which they're stored. And that certainly creates complexities, because you think about the time grain that this data exists at. So I've added this as well into sort of the charts. You can see some are at a intraday or day level, some are at overall sort of more of a month level in the billing cycle, so in terms of particularly around the retail bill volume. So that's probably 2 to 3 months. But what this means is that you have data that you need to compare and reconcile that happens at different grains, at different environments, and that's obviously very challenging. So but it's a key activity to do. And obviously you want to remove the friction in that, because there's a lot of money that potentially gets caught up in this if we don't do it quickly and we don't do it well. Cloud offers ultimately us an opportunity to tackle this. And how does it allow us to tackle this? I guess really it's because you can really spread your compute across the different runs. You put all your data into the cloud, and that's not a trivial task in itself, mind you. But what it allows you have these separate streams that effectively then what you can do for where each of these data sources reside, you can specify the compute, and by the compute, that means the resources that are needed to process each of these. So one of the things that I guess is often sold about the cloud is vertical versus horizontal scaling. And so to traverse that reconciliation process between those four usage types, if you're having, for example, with purchase volumes, where there's not a lot of data, you don't really want to scale up to a lot of compute, which is in this picture represented by the number of processing nodes that you kind of see. So, but when you're starting to work with the big data, we'll say in the AEMO sort of usage data, or you're talking about the network data, you're probably going to want to scale up because that's a lot of records you're going to have to process and analyze and to build in some sort of shape that you can actually reconcile the volumes against. And so in that case, then you're probably going to want to use a combination of horizontal vertical scale that you actually wouldn't be able to do on-prem. So when I talked about at the start how they sit in different environments, one of the things when they're on different environments as well is those environments are typically constrained about the resources and the processing power they have. And we don't do this reconciliation process every day. We do it regularly enough, but certainly by what we can do is that on the cloud, instead of having dedicated on-premise infrastructure that is very powerful to do certain aspects, we only scale up vertical or horizontal when required. So for example, if we needed to process the metadata into a shape that allows us to reconcile against the build volumes in the retail side, in the purchase volumes, and the network volumes, we can basically specify for a specific time and to run it. And that's what cloud allows us to do, and to do that quite quickly. Because we can have different compute assigned to the different tasks, whereas on traditional on-premise infrastructure, you can't do that. You're locked into having the one type of infrastructure for everything. So you kind of have this sunk cost that you're using all the time, whereas in cloud, you only pay for it as you use it. So we basically are going through a process where we only specify the compute and the processing for these processes to happen at certain times. And there's a few smart things in that you may be aware of around on AWS, which is what we're using, that you can find spot prices that tend to be cheaper to run your processes. So it's possible to find a cheaper time of day to run that and actually bring in bring down the cost of actually running these things too. So ultimately, I think if I'm to summarize what I've talked a bit about today, coming to the cloud is a bit daunting. It is quite complex. I'm not going to make it sound trivial, but the energy industry is complex too. And within that, the cloud allows us to deal with a range of those complex issues on a more strategic basis and a resource relevant profile, as opposed to currently dedicated resources that can sit idly for a long time, particularly large tasks that we don't have. So the cloud brings you that speed and that ability to choose when you want to transact. So we talked a bit about also in our particular use case, usage reconciliation is a very complex process. It's a very important process to all players in the industry. It's typically very hard, and there's a lot of dollars on the line, generally in the millions of dollars. So getting that right is really fundamental. And one of the things about coming to cloud, hopefully I've made clear through this presentation, is that it allows you to scale up and work with this big data that traditionally is very hard to deal with on premises. So hopefully you found that useful. Any questions that you may have, feel free to chuck them in the chat. My understanding is from Karen is that they'll be put there, and I'll log in and reply to them. If not, reach out to me on LinkedIn. So always available for a chat. And then we can move from there if you have any questions as well. Thank you very much.